right, running with that. Cool. Yeah, that was a fast quarter, wasn't it? Um, and it was a long one. It was 11 weeks, and it still felt like it went really quickly. Um, all right, let's start with questions. Anything from the study guide or from the rest of the course or from computer science that you want to ask about, talk about, discuss?
So I'm looking at the study guide right now, and you mentioned under batch programming something about detecting EOF. Can you remind me what that is?
So that's this question of like if you're reading from standard in and you want to read lines until the user hits Control D or an input file hits the end of the file. So the easiest way to do that is with a while read. So if I say while read in the name of some variable, that's just like read variable, except it's in a loop which will continue to iterate until the person hits Control D or the input stream hits the end of the file, and then you'll exit the while loop. And so a typical example might be like this. So let's just count the number of lines of input from a file. So count equals 0. So a really simple version of word count, which reads reads standard in and tells you how many lines were ingested. So I can say hello, this is a test 1, 2, 3, and hit my Control D, and it'll tell me total number of lines read was 5, right? Or if I said something like cow say hello, which gives me this, and I pipe that into main, it tells me it read 7 lines, and if I look at cow say, it should have 1, 2, 3, 4, 5, 6, 7 lines, or something close to that. And if you know, my main program is 9 lines in length, if I say let's feed the contents of this main file into main itself, it'll tell me total number of lines read 9. So this is reading standard in either from the keyboard or from redirection, and counting lines. So that's an example of detecting end of file, is using this while read structure. The other approach that you can use is something like this. Make yourself a forever loop. And then check your status. And we can do something like if the status of the read statement is not 0, we know that we hit end of file, and so we can break out of our do loop, and this should do the same thing. Right, so read 3 lines in just 14 lines. So those are 2 ways to detect end of file and respond to it. All right, let me make a comment about winter quarter. Only about 2/3 of the students who are in 224 have signed up for 222. And if you're leaving computer science or switching majors or something like that, then you probably don't need to take CSE 222. But if your goal is to continue in the computer science program and transfer to a university and pursue a bachelor's in computer science, you need CSE 222. And if there's a sudden run, the week before classes start, and 20 people try to sign up for, the 5 spots that are still available, there's going to be a potential problem. So if you're planning to take CSE 222 in winter, sign up for it as soon as possible. And if you're planning to do computer science, right, you probably almost certainly need CSE 222. And you can sign up now. Yeah, I wouldn't wait to see what happens on the final. For one thing, I don't know if people are signing up for other classes or waiting to see what happens with those, but a lot of classes are filled up already. We've got 2 sections of CSE120. They're both completely filled up right now, and there's wait lists on them. If that's representative of other classes, I know math classes are filling up. I've got students coming in trying to sign up for one class, and they can't do it because, the other section they need of this other class is filled and stuff like that. So registration is kind of like, it's something you gotta deal with pretty aggressively. And, the moment that registration is open for you, you really want to go sign up for classes. You can make changes later. You can drop classes, you can move things around if you need to, but if a class is filled up and then later on you try to sign up for it, that's really hard to make work sometimes. And so yeah, someone says that physics classes don't seem to have wait lists. And physics, everybody is going to be taking that. If you're an engineering or computer science major, and so those get filled quickly too. So that's
the few online options like filled up really, really fast.
Yeah, and I'm not sure which is most popular right now, the online or the in person. I've heard people saying for a year how much they dislike online classes and can't wait to get back in person. But the online ones seem to be filling up quicker from the few cases where I've looked. And so that's a complex issue because depending on your trust of science and mitigation measures, it's not just personal preference sometimes to say I want to do this class or that class, or I want to sleep in, or I want to get up early, right? Sometimes we've got real concerns with, should we be in person, should we be online, that kind of thing. So that makes it trickier too. But again, register early and you got a better chance of getting something that meets whatever your criteria are. Yeah, I will be very interested to see how CS classes in person play out in winter. And I don't know all of the details of that, but a lot of times what I was doing in my classes before COVID was having people work at the board in groups, and I was working with kind of flipping classes where we'd do a little bit of lecture, but mostly students would be solving problems. And I don't think we're in a space now where I can have 4 students standing next to each other in front of a board collaborating on a problem. So I don't know how this is going to play out. It'll be interesting. But make sure you get into some class, and we'll make it work whichever way it goes. All right, so that's my PSA for registering early. All right, other questions before we just kind of continue through this study guide? Alright, well, let's continue looking at final exam. And if you were not here yesterday, let me repeat, final exam is Monday, 10 o'clock to 11:50. And it will appear as a Canvas entry. Read the questions from there, type up your answers, save them as a PDF, upload by the deadline. How many questions will there be? There will be 3 or 4 programming questions, and then some number of short answer, fill in the blank, matching kind of questions. And I haven't decided how many, but those will certainly be quicker than the programming questions. And the programming will be a mix of Bash and C.
I have a question.
Yeah.
Do we use our normal Zoom entry, or is there a special entry for this time?
So, you're not required to be on Zoom, but I strongly recommend it, and it would be the regular Zoom that you used to get here today. And I'll be in this Zoom classroom during the entire exam, so that if there's questions or clarifications, or if I made typos or stuff, I can tell people about that. So, yeah, I recommend being in Zoom, and it would be the same Zoom link as usual. But the exam actually comes through Canvas. Alright, well, go ahead and send an attendance note. Possibly your last attendance note of the day, of the year. Possibly forever. Because I don't know if I'll keep doing attendance. Alright, and let's just keep marching through the topics. So, we talked about processes, and processes, I was interested in basically the higher level concepts, just sort of the overarching themes there. So, and then some particulars about fork and Control-Z, background, foreground. File systems. So, there's this whole file system concept. There's a hierarchy of files. You can do PWD to see your directory. I'm in a directory called Nick, underneath a directory called home, underneath a directory called slash. Slash is the root file system. I can say CD to go into a directory. I can say CD home and see all the users in the home directory. I can CD slash and see all the things in my root directory, including home, but also other stuff like etc. and bin and so on. So there's this whole hierarchy of directories, and we can move around that hierarchy by using commands like cd, which is change directory, and pwd to print our current working directory. Working directory is just the directory you're in. We also have these special directories. Dot is our current location. Dot dot is our parent directory. So if I say let's go into my 221 directory, or my 224 directory, right? So this is my current directory. If I say cd dot dot, now I'm one level up under 224. If I cd dot dot, now I'm under files. If I cd dot dot again, that'll be home Nick. If I go up another level, that'll be home. If I go up another level, that'll be my root directory. And if I try to move up from there, I'm just going to stay in there because that's the root directory. There's no way to go to a higher level than that. And you can do things like, I'm under home Nick files 224. I could say cd dot dot slash 215. And I've moved up, that's what the dot dot did. And then I moved down, that's the 215. So now I'm in home Nick files 215. So you can bounce around directories, and you're probably used to this from being in Unix. Hidden files are just files that begin with a period. That's really all there is to know about them. A file that begins with a period is hidden, and by default ls doesn't show you hidden files. And so if I say ls, I see, a handful of files like this. If I say ls-a, that tells ls, hey, show me also the hidden files. And now we see there's a whole lot more stuff in here, .wine, .npm, .exrc, and so on. Alright, and you should know about file permissions. In particular, when you want to make a file executable, you can turn the permissions on for the execute bits. And so, for example, this main program, I needed to make it executable so that I could execute it by default. By default, when you create a file, there's some permission bits that are set that usually don't include the execute bit. So if I try to run main2, it'll say permission denied. So you can say change mode, and you can put in a 3-digit octal code that correspond to which of these bits you want to turn on. A 1 means turn a bit on, 0 means turn it off. So if I want all 3 bits to be turned on here, I can make that a 7. If I wanted nobody else to have access, I could make this a 700. Main2, and if I look, there's the bits corresponding to the 7. I have read, write, execute access, and then people in the group and people outside of the owner and group don't have any access. But I can execute this now.
So when you do exclamation mark ls and then type in ls-l.
So sorry, say that again?
When you type in exclamation mark ls and then a waste for input and then you put in ls-l.
So if I say exclamation ls, it will recall whatever my last ls command was, which in this case was ls-l. If I say ls-a, and then I say exclamation all ls, that says recall my last ls command, which in this case would be ls-a. So exclamation anything goes through your history and finds the last command that begins with whatever you typed. And that's a little dangerous to use sometimes.
Why?
Because maybe I'm got a program called run, and I keep saying run, and then I like switch to a different window and I want to run, and so I say exclamation mark R, but maybe in that window the last command I typed was like rm asterisk, and so now I accidentally delete all of my files because I didn't remember correctly what my history was. So that kind of thing can happen.
I see.
Unix is so kind of like, you know, anything you want to do I will do for you, that you just need to be a little careful when you type commands if you're not actually typing them in explicitly, because it'll do whatever you tell it to do. You can set up defaults that will say, you know, ask me for verification every time that I try to remove a file, but, you know, a lot of people find that annoying, and so by default those safeguards aren't in place. If I say, you know, rm star, it deletes everything in the directory.
How do you undo that?
You don't. Those files are gone. You might be able to find an undelete program that could, like, you know, scrape off most of it from the sectors on the hard drive if they haven't been overwritten. But if you say rm star, all the files in your current directory are gone. If I do this from my home directory, my entire home directory is gone. And if you do an rm-rf star, you can wipe out your entire directory tree. And, you know, the only way you undo it is to go to a backup.
Like with Git?
If you're pushing things to Git, that will get you there. I have backups running every 6 hours on my machine to an external hard drive running on a different machine on a local network. So if something happens, if my hard drive fails, or I get kind of boneheaded and accidentally delete all my files or the files in a directory, I can get a backup from like 6 hours ago. But yeah, it's kind of the Wild West. but Git's a good way to circumvent some of that. If you have one directory that you're working in, and you're doing lots of stuff in there, you can just have a Git repo and keep pushing things over to Git, and that will sometimes save you. Also, if I do git init, right, and I actually say rm star, by default my hidden files don't get removed when I say rm star, so I still have my Git repository here, and I could still use that to go back and get my files even if I haven't pushed them over to a remote machine. But if I move up one level and I wipe out this directory, which is my CSE224 directory, then all bets are off, and it's pretty much gone. Let's see, quick question, is the final exam open book like the midterm? Yes, so good question. Final exam, open book, open notes. You can use copies of your code that you've written for ODPs or programming assignments. And that's it, right? So no Googling. I do not want you using a compiler. I don't want you using, an editor that completes your statements for you or things like that. So
GitHub AI.
Say again?
No GitHub AI.
No GitHub AI. No Skype. All right, let's see. So permissions, change mode, setting variable values. So we've done this all quarter, right? So you can say variable equals some value. No spaces. Never put spaces around your equal sign. It will confuse bash. If I say x equals 2 plus 3, x will be equal to literally 2 plus sign 3. If I want to evaluate $paren 2 plus 3. That's the only way that you're allowed to do this on an exam. If you use EXPR or bracket or things like that, you don't get credit. So if you want to do arithmetic in bash, $paren, put your expression inside here. When you want the value of a variable, put a $sign in front of it. Don't worry about exporting variables. We talked about that once, but I'm not going to ask you about that. But that's the idea that basically, if I say something like this, x equals 12, and I start a new bash session, which is what happens when you run a script, my value of x, doesn't exist in this instance of bash. If I say export x, and then I start a new bash session, my value of x got inherited when I started this new session. So if you're running a script and you want your script to be able to read the value of x that you set up in bash, you want to export x first. But I won't ask you about that. And then built-in variables. So if you run a script, $1, $2, $3, and so on, those are the arguments specified to the script. $question mark shows you the status of the last command that was executed. So we've used that, to see if something succeeds or fails. And that's probably all you need to know. $sign is my process ID, but we don't use that very often. $number is a number of arguments that were passed to the script. $asterisk is the string of all the arguments tied together into a single long string.
Is that going to be on the exam?
It might be useful to know.
Yeah, it is useful to know for sure.
I'm not going to get fancy here. I'm just going to say $number, and I'll show what $number is, $star, and I'll show what $star is. So if I say main, this is a test, $number will be 4, $star will be, this is a test. So it's the whole set of arguments that you passed. You should know the dialog command. You had a whole programming assignment, so I expect you to understand basics about dialog. For example, if you want to display a piece of information or read a line of input from the user or display a calendar, those kinds of things. And in addition to knowing, the arguments for dialogue, you should know how to capture output from dialogue. So if I want to read input from the user, I can do a dialogue with an input box. But by default, dialogue takes whatever input it gets and sends it to standard out. So you have to do that -- output -FD business. So go back and review what you did.
Fair game for the final.
Say again?
Are the man pages usable on the final?
You can use the man pages, sure. I'm okay with that.
I'm going to say the dialogue command is kind of an iffy.
Know how to do input, know how to do output, know how to do a calendar, and you'll be fine. I'm not going to ask you to make menus or get into radio lists or things like that. I'm more interested in the ability to do things like capture output or, construct a thing that you're going to display in a message box using some variables and something that the person typed in or something like that. So, not so much the dialogue command itself, but knowing how to use it and interact with Linux at large. So using backquotes to capture input or $signs for variables, things like that. You should know how to use GCC, -O to specify an output file, -C to compile without creating an executable, but to create an object module, -G to say link in with GDB for debugging, and -LM to link in the math library. So those are all things we've used, so you should be comfortable with those. GDB, you should know the basic commands. How do you compile for GDB? That's the -G switch. How do you run GDB? GDB file name. How do you start? That's the command start. How do you set a breakpoint? How do you stepping into a function, stepping over a function, printing the values of variables, examining memory, all of those kinds of things. So go back through your notes on those. Make files, so you should know how to create a make file. You should be able to write a make file to, compile pieces of a program and link them together. If I give you a simple make file, you should be able to answer questions about it. So I could give you a make file and say, if you say make and then you edit this file and then you say make again, what commands will be executed? What will be compiled? What are the GCC commands? Or I could say, add a new file to your project, name this, it uses these files, go ahead and update the make file. So make sure you know about make files. Regular expressions. Main things I want you to know on regular expressions are, the idea of looking for a pattern, where a pattern is a series of characters, or a wildcard with a dot, or a succession of characters with an asterisk. You should know about anchors, so the caret and $sign for beginning of the end, and using parentheses to put things into registers, and then \number to read the contents of a register. And that's all you need for regular expressions. And so that worksheet that we had a few weeks ago with sample problems to work on, that's a good practice sheet. SED, the only thing I want you to know for SED is how to do basic substitutions. Again, the things that you were doing in PA4 most likely. So SED, substitute old, new. And know that this reads from standard in or it reads from a file. But if you don't specify a file, it will read from standard in, which means you could redirect it from a file, or more typically you could pipe something into standard in. And if you put a /G after this last slash, the replacement you're specifying will happen everywhere possible on the line. If you don't put a /G, the replacement happens exactly once. And then awk, the only thing I'm going to ask you to do there is use awk to print out fields from a line. So we're not going to ask about, all the programming options and instructions and things like that. SED is just doing substitutions. Awk is just printing fields, so taking an input and saying something like this. And so this, for example, would read from standard in, break each line into fields separated by spaces, and this would print out the third field, a dash, and the first field. And the one switch I want you to know is if you want to specify a different separator other than a space between fields, do a dash F and put in, you know, a pipe, for example, which you escape, or a slash, or a comma, or whatever your field separator is. I think that's it for basic Linux. Bash programming, so know about the shebang. This has to be the first line of your program if you want it to have any meaning. And this is the name of the file which will be used to execute a script if you just type the script name. So when I say main, if the first line says $! blah, then the program blah will be used to execute main. So we usually make this /bin/bash. $! begins a comment. This is technically a comment, but if it's the first line of the script, it's also got this special meaning. But more generally, $! followed by anything is just a comment. We talked about these variables. We talked about $! We talked about variable assignment. If statements. So I'm going to continue to say the only way you are allowed to do if statements in bash is in one of these formats. If space bracket bracket space condition space bracket bracket, then body of the if statement phi. With the option of, you know, if you have multiple statements, you can link them together, like, you know, and bracket bracket some condition, or bracket bracket some condition. And if you want an else statement, you could say else statement, and then phi. If you want your else statement to be an if statement, you can say else if condition, then blah blah. And you can chain these things together as much as you like or need. Right? So there's that bash how-to guide on Canvas that we've been referring to throughout the quarter. So that's your best guide for what are you expected to know and be able to do with if statements and with loops. So for while loops, again, while space bracket bracket space condition space bracket bracket, new line do, body of the while loop, new line done. The only for loop you're allowed to use is for variable in list. Right? Look back at PA5 for reference on that. We know about back quotes. We talked about those yesterday. Execute a command, take the result of standard out, save it in this variable. $paren to do arithmetic, basic statements like read and echo, detecting end of file, which we talked about in the very beginning. Know about associative arrays, right? So make sure you know the syntax of those, and that you know the concept of them. So the syntax is like declare dash uppercase A, whatever your array is called. And to assign a value, we can say name of the array, bracket whatever equals whatever. And to read the value of an array, it's $ curly bracket, names bracket whatever. Don't try to read the value of an array by just saying array bracket index. It's accepted by bash, but it does not do what you want. And then the last piece is this business of reading the keys out of an array. And this is this $, bracket, exclamation mark, name of the array, bracket, @. this gives you a list of keys. And then if you want to iterate over that, typically we'd use a for in statement. So again, PA5, right? By and large, if you've done and understood the ODPs and the programming assignments, right, you should be in pretty good shape for doing what you're going to see on the exam. If you ended up getting your programming assignments to work, but you're not sure how they worked, or you ended up having to do something very different from what we've gone over in class, you definitely want to go back and look at those before the exam and make sure you understand you know, the mechanisms and concepts as we've presented them, so that you can generalize those. And again, make sure you understand algorithms, right? A lot of this is going to be about coming up with an algorithm to do something and then writing code to do it. But the first step of programming is, you know, what are the steps I'm going to do to solve a problem? And then, you know, what are the steps that I can tell a computer to do to solve the problem? And then how do I actually write those steps in a language that the computer understands? And that's as far as we go on these exams in the field. The fourth step would be, okay, now let's go ahead and put that into an editor and test it. And then if it doesn't test correctly, let's find what the error is and fix that. But we don't get to do that on the exams. All right, C programming. Feels like this was a long time ago, right? Basic syntax, assignment statements, declaring variables, if loops, for loops, while loops, if statements, for loops, while loops, and so on and so forth. Make sure you understand characters, and you know, a character is something like this. And this is synonymous with the integer 65, that's its ASCII code. If I use double quotes, that is not a character, this is a pointer. It's probably a 64-bit number that points to somewhere in memory that contains the value 65. But if I try to compare this to, you know, 65, or I try to change it to uppercase or something, I'm going to segfault most likely. You should know how to make comments. Include statements, so number sign include angle bracket, or number sign include quotation marks. And these take the contents of a file and pull them into your current source code at the point of the include. Angle brackets are usually used for system files where we don't want to specify the full directory path. They come from a default location. Quotes come from whatever path we put inside the quotes. If it's just a file name, it's our current directory. If it's got, you know, slashes and dots and things, it follows whatever the path is. We mostly work with integers and characters, occasionally doubles, but also pointers to these things, pointers to characters, in particular being strings. Think about modularizing code. Keep in mind the difference between including a file and listing a bunch of files when you compile. Right? I never really want to include a .c file in another .c file. If I do that, I may as well just take the contents of that first .c file and type it in, right? If I have, you know, some functions defined in here and some functions defined in here, and I want to use them inside here, I probably want to link them together using GCC. If I have a declaration of a structure, or a define for some constant, or prototypes for 100 functions, I probably want to put those in a .h file and include them, so that it acts as if I had typed those in the beginning of my file. So keep that difference in mind. Character arrays, these are strings. Sometimes we do char star, sometimes we do char variable bracket bracket, sometimes we just say char star equals double quote. But these are all different ways of defining strings. By definition, by convention, strings have null terminators at the end. It's a character with ASCII 0. But arrays don't have an inherent length in C. An array is really just the address where the array begins. And the only way we know how long a string is because we agree that we'll put a character 0 at the end of the string. So things like string length and string compare will search through the characters that make up a string, and when they get to the first occurrence of a character 0, they say that's the end of the string. String length is a good way to find the length of a string, number of characters, up to but not including the terminator. String compare is the only way to tell if two strings are identical. If I have two character pointers and I say, is character pointer 1 equal to character pointer 2, the answer is almost always going to be no, even if the things are pointing to identical strings. So if you want to compare the strings themselves, use string compare. And you should know what it returns, which is 0, positive, or negative. Math.h is where we get math functions like, absolute and square root and stuff. String.h is where we get things like string length, string compare. C-type is where we get things like is space, to upper, to lower, is digit, stuff like that. I don't know if we actually used C-type.h, but if you have done any conversion to like uppercase and C, this is the way to do it. You should understand pretty well what a main program is in C. Right, it has to be called main. These arguments are optional, but if we have arguments, there's a pair of them. The first is an int, the second is a char star star. And you should know what these mean, right? argc is the number of arguments that were listed on the command line when the person ran the program. argv is an array of those strings, one entry per command line argument. argv bracket 0 being the name of the program, and then it goes from there. Make sure you check argc before you check argv, unless you have some assurance that you have at least a certain number of characters. If you're told you're always going to have 3 characters, 3 strings on the command line, then you can go ahead and look at argv 0, 1, and 2. But in general, the only way we know that we have a certain number of arguments is by looking at argc. You should know how to use scanf. You should never use scanf. Except in extremely controlled circumstances. If you're guaranteed that the person's going to type an integer, you can get away with scanf. But in general, you want to use fget combined with scanf, or scanf, to do ingest and parsing separately. Printf for printing, you should know about that. Basic file I/O, fopen, close, fflush, fprintf, and fgets, which we use for standard in, but we can also use for files. fgetc we haven't really used, but if you want to read a character, you can do that. You should know why you should not use gets, right? Gets has no limit on how many characters are ingested, so it's a buffer overrun potential. You should know how to make functions in C. Let's see, someone said some compilers have their own version of scanf. Yeah, I believe that. You should know how to write functions, how to pass things to functions, how to get things back from functions. The idea of a function's return value, which is when you say something like, I equals my function ABC, right? This is going to get what we call the return value from the function. And inside my function at some point, there's going to be a return statement that returns, something. That's something that's going to be the return value from the function. That's what's going to, in this case, get assigned to that variable I. And even if I'm passing things with an ampersand in front, I'm passing the address of something, and my function is changing the value of C by using that mechanism, right? There's still this idea of the value that it gets returned with a return statement. That's what's going to get assigned here. So calling functions, passing arguments to functions, returning values from functions. And then again, make sure you're thinking in terms of algorithms, right? How do I do something? What are the steps I put together to achieve some goal? And then how do I, express that in C in this case? So some of the things that are useful to keep in mind are things like running sums, right? Where you have a sum that's initialized to 0 and then you keep adding to it. Using flags where you set or clear a value in a variable to record that something has happened, but you want to act on that fact later on. So you put a value into a variable to say, hey, if you see this value later, it means such and such has happened. Initialization, make sure if you want a variable to be 0, you set it equal to 0. If you want it to be 5, set it equal to 5. You always have to initialize variables in C. And then basic concepts like looping to perform the same action over and over again, conditionals to perform or not perform some set of actions based on some condition that you don't know until the program's running. For example, did the user type in the number 55? And if they did, then I want to do, you know, some special behavior. So that's a conditional statement. All right, well, there's CSE224 in like 35 minutes. So final recommendations, I guess, would be, you know, go back and review the ODPs, definitely the programming assignments for the programming parts, and make sure you really understand what you did in those. And if you were fuzzy on some of it, try to get some clarity on that. Make changes to your code, maybe rewrite the code from scratch without looking at the code. These are good ways to really test, you know, do I understand an associative array? Start with, you know, your notes on the 4 or 5 things we need to know about associative arrays, and see if you can reproduce PA5, right, or some piece of PA5 or some piece of test code that does similar things to PA5. And for the Linux part, right, again, if you've been working in a Unix environment for 11 weeks, you should have encountered most of these things, you know, multiple times. But if you've, you know, lived all this time without ever having to you know, move around a directory, and you're not sure what ... means or what pwd means or something like that, right? Go back and look at your notes and refresh yourself on those. And then try not to stress over it, right? Try to come to the exam without, you know, having your knowledge falling out of your ears because you've stuffed so much into your head. You've been doing this course for 11 weeks. You've done a bunch of assignments. There's a really, really high probability that you know this stuff better than you think. So do some review, especially on the older stuff. We haven't talked about C for a while, so go back and review what you did for those, review your notes, and then you know, just come in Monday and demonstrate that knowledge on the exam, and don't stress too much over it. Do not miss your exam though, because that's a really bad thing to try to deal with. So make sure you show up 10 o'clock for the exam. I recommend being in Zoom so that I can give corrections and so on and so forth. And that's pretty much all I got. So have a good rest of the day. If I don't see you in 2:15, I will see you on Monday. Send me an attendance note on the way out, and hope you have a good one, and I'll see you next week.
Bye.
Thank you.
All right.
Weekend.
You too.
Have a good weekend.
Thanks, you too.